Okay, so as I mentioned, we're using a pre-release version of MSO, and one of the things that's been added are a pair of import wizards, and these greatly simplify getting MSO set up and ready to optimize your subs. I think the learning curve for doing a lot of this stuff manually was probably the biggest barrier that folks had to getting to know and getting to learn to use MSO. And this version that Andy's got coming really simplifies that with the wizard. Basically, 90% of the work is really, or more actually, has been done for you with the wizards. So, if we go here to file at the top, down at the about the middle of the file, in this middle section here, there's this measurement import wizard that we're gonna start with. So let's go ahead and click on that, and it's going to ask what kind of data that we're going to be importing. MSO can do a couple of different types of optimizations. One is a sub-only optimization, and then the other one is a sub and main speaker optimization. The sub and main speaker optimization can be used to not only optimize your subs to work well together, but also to optimize their integration with either your left and right speakers, your mains, or your center channel. We're not going to get into that today. We're just going to walk through a sub-only configuration. If I get the motivation, perhaps I'll walk through a sub and main speaker data integration as well. But we're just going to do a sub-only optimization today. So if you go ahead and hit next, it's going to say, hey, what measurements do you want to import? So we're going to click Add Files, and then we're going to go find where I exported or where you saved those files that we exported from MSO. And here you can see just exported a few minutes ago based on the timestamp of the system. These are all the files that we just exported from REW. So if you click the first one, and if you go down to the bottom one and you hold the shift key and click the last one, that'll select all of those files at once. And you can say open, and they're all going to appear here. There should be 12 of them, which there are. And then we'll go ahead and we'll click next. And it's going to ask you if you want to either just import the measurements or if you want to run the configuration wizard. We're going to go ahead and run the configuration wizard because this is the piece that really simplifies our lives as MSO users. So if you click finish, it's going to run through the import, which is pretty quick. And it's going to start the configuration wizard immediately on import. And it's going to ask us a couple of questions. So the first thing we want to know is it's made some guesses on how many subs and how many listening positions that we've got. So we just want to verify these numbers and make any corrections to our counts here. So as I mentioned earlier, I do have 4 subs in my config. If you have 2 subs, if you have 6 subs, whatever you've got, you can enter in the number of subs for which you've got independent measurements here. The next one is, hey, how many listening positions have you measured? I mentioned earlier I've got 3. If you did 4 or 6 or 9 or whatever you did in your theater to import into MSO, let's make sure that you've got those in there. The most important thing is these are how many measurements we've imported. So for example, if you've only if you're running through this with test data and you've only done the first row of your theater and you've only got 12 measurements, make sure you've got 3 seats and 4 subs, or if you've got 8 measurements, maybe you've got 4 seats and 2 subs. Just make sure that this corresponds to the number of measurements that you've actually taken and imported. Go ahead and hit next. And now it's going to ask, hey, what are the names of your subwoofers? It's just got them listed as 1, 2, 3, and 4. That's great if that's what you call your subs. That's not what I call my subs. It's not super intuitive for me. So you can go ahead and actually edit this and give your subs proper names. So if you click on a sub and then you hit F2, it'll let you change the name of it. And I'm just going to match the names that I used in REW because that's how I think of them in my theater. So I have a left front sub. Click on the next one here. I have a right front sub. I'll click on the next one. I have a left rear sub. And then I also have a right rear sub. So those are my sub names: left front, left rear. Make sure they mean something to you whenever you input yours. And then we get to do the same thing for our listening positions. So as I mentioned, I've got a 3-position couch. I've got a left position that I'm going to use. I've got a main listening position in MLP. You could call it center. You can call it Steve, whatever makes sense to you. And then I've got a right listening position. So I've got my positions in here named. And again, that was click on it and then hit F2 to make the change. It's the same for the subs as it is for the listening positions, and go ahead and hit next. And what we're presented with is a nice little matrix. The matrix here has our custom position names, left, MLP, and right, and our custom sub names listed out underneath each one. So I've got a left front, left rear, right rear. I've got the same for my MLP and the same for my right listening position. And what we're going to do here is we're going to associate a measurement file with a position in our theater, right? So if we click this little drop down on the right hand side, it's going to show all of the text files that we've got. And remember when I told you you want to name these something in REW that makes sense because it's going to make our lives easier? This is where it makes our lives easier. If these are just called, for example, 1 through 12, you're not going to know what's what. And it's really, really important to make sure that you have the proper measurement associated with the proper sub at the proper position. So for each one of these, we're just going to go through and we're going to select which sub matches up with which measurement for each of these. Right rear. So now I'm on MLP, left front, MLP, left rear, right front rather, and right rear. And the same thing for left front, left rear, right front, and right rear. If you've gone through this and accidentally selected a file twice, it'll throw up a little error message that says, hey, you've got the same measurement selected 2 times. Go and double check that. Again, make sure that these are correct. This is pretty important. If you have something that's associated incorrectly, like you have 2 different subs swapped in the position as they're associated here, your results are going to be completely invalid, right? So we want to make sure that these are mapped correctly. Once those are mapped, go ahead and click next. It's going to create a template. We're not going to go into templates right now. Templates are used for creating configs really, really quickly from scratch. We're just going to leave this. We'll just call it subtemplate 1 so we can accept the defaults right here. And we're going to give this config a name. Now, I always like to use an initial config that's called baseline, because that gives me something that I can always return to, that I always know is going to be my basis for comparison for my starting point. We're also not actually going to make any changes to baseline, so it makes it easy for us to also, just like using the template, it makes it easy for us to duplicate our config later. So the next thing we need to specify is how many PEQs, how many parametric EQ filters we want to use per sub. This is going to vary, or can vary, depending on the hardware that you have. I think the vast majority of people are using a mini DSP 2x4 HD. That's what I personally use. That's what I highly recommend you use. The HD has a better processor in it. And as a result of that better processor, it supports a lot more filters than some of the other models like the standard 2x4. If I remember correctly, the HD will support up to 10 filters on the input channels and 10 filters on the output channels for PEQ. Where do we start with this number? So I know I have 10 available. I don't really want to use all 10 initially because I may not need all 10. I personally tend to start with half the number of filters that I've got available. This is just my personal thing. You could start with 4, you could put all 10 in there. It really doesn't matter. The reason I like to start with half is because I want to see where my optimization kind of gets initially. And then I can add additional PEQs, or I can add more PEQs if I want to target certain things within the range that we're going to optimize. So we'll talk about that optimization range here in just a little bit. We're going to use, for the mini DSP 2x4 HD, we're going to use the RBJ Q definition. If you're using other hardware for your subs, like Behringer iNuke or some other non-mini DSP hardware, you may need to use this legacy definition. Most the help file here in the little pop-up kind of walks through why. If you're not using a mini DSP 2x4 HD, go check the documentation and understand when you should be using this. The rest of this stuff we're going to leave checked. So we want to add gain blocks to control the gain of our subs. We want delay blocks on all of our subs. And we want to go ahead and have it create a graph for us and launch the graph properties when we're done. And then we're going to launch the optimization options when we're done as well. So let's go ahead and hit finish. And it's going to create a bunch of stuff for us. The first thing that we've got is we have an initial graph of the sub responses at each listening position. So I've got three charts here, or three SPO graphs rather, response graphs. One for the left in blue, the MLP is in red, and the right side is in black. And again, this is my actual data. So I want to change the title of this graph before I do anything. So this is going to be the title that actually appears here. So I'm just going to call this baseline, baseline. If no one can type when everybody else is watching, right? Baseline listening position responses. If you hit apply, it'll change it on the fly, but leave this open, which is great. I want to make a few small changes on the axis as well. The first thing that we want to do is this is fine, I think, for most people. I do tend to optimize a little bit lower because my subs have a lower frequency response. So I'll optimize down to, maybe you'll choose 15 hertz, maybe you'll choose, 12 hertz, just kind of where your subs are responsive to. I actually implement a high pass filter to kind of protect my subs. So I'm going to look at things from 18 hertz to 150 hertz. Actually, let's leave it at 200. That's fine. And we'll go ahead and hit apply. Now let's take it down. Let's just look at it bigger. That'll be fine. We'll go to 10 hertz. So there we can see my response down to 10 hertz on my subs. The y-axis, I always like to change this a little bit. First of all, you can see that this kind of pops up to about 105. And I want to try to get this a little bit closer to what I'm used to seeing in RAW, which is a 5 dB scale. The responses here are going to look pretty different because it'll automatically change this scale. So I'm going to change this. And I'm going to give myself a little bit of room because we're going to separate some graphs here in a minute. And we want to leave room so that we can have multiple charts on the same graph. So this is going to give us some consistency, right? So I'm going to change this to 40 and 110. And that's really all we need to do on this graph for now. So let's go ahead and hit OK. And if you remember, we had a checkbox on the optimization options as well. We'll walk through this real quickly, but we'll get into it. I'm just going to walk this through from what the settings look like. And then when we get into a config, we'll talk about the different values that we're going to use. So it is best practice to just use the minimize seat-to-seat variation. Some of these others are used only if you're doing a mains integration, which is why these options are grayed out. We can talk about the criteria. The criteria is where we specify the range that we actually care about, optimizing in our environment. I'm going to go ahead and change this right now, and we're going to change this to, because I want this to flow to my other configs. I'm going to change this now, and we're going to go ahead and optimize from 15 to 150 hertz. I tend to, you could go up to 160. They'll say that the best practice would be, what's the highest frequency that you plan to use or you think you might use for a crossover, and then go an octave above that. And the reason is that crossovers are not a cliff. Crossovers have a slope depending on the actual slope that your AVR or your room correction software uses. So that's the recommendation. So if you think, hey, 80 hertz is probably what I'll end up using, or something around 80 hertz, maybe you want to take this up to 160. If you're going to do something like 100 hertz because you have some smaller speakers that don't play quite as deep, maybe you take that up to up to 200 hertz, right? So this next bit down here at the bottom is how long you want to run the optimization. For lack of a better term, MSO essentially brute forces uh, the optimization parameters. So it computes the different delay combinations, the different parametric EQ combinations over and over and over again. And it'll run for as long as you let it run. So if you told it to run here for, you know, for 300 minutes, it's going to sit out there and it's going to churn for 300 minutes. But what you'll see is there's usually a little bit of a diminishing point of returns. We don't want to spend, too much time sitting there waiting. Personally, I mentioned I'm running this in a VM. It's actually up in AWS. So I'm paying for compute on these things. So we're going to leave this. You can leave this as it is, depending on where you're running it. I'm going to add some consistency to this. I'm not going to run anything longer than 20 minutes, and I'm going to cut the optimizations out of the video so you can just kind of see the before and after. But we'll run everything for 20 minutes for the purposes of the video. This next one, TEQ parameter limits, this sets the parameters for the individual PEQ filters on each sub. So what we want, there's a few things that we want to tweak in here. We'll go into some of these in a minute because some of these, particularly this, particularly the maximum cut items and then the constraints that are related to these on the next page are kind of dependent on this reference level that we're going to talk about here in a few minutes. So the important thing to know is that if your criteria is from 15 to 160 hertz, which is what I've done here, you want your parameter limits for your center frequencies to match that. Okay, we don't want to accidentally limit where our center frequencies for our filters can be placed to something that's less than our optimization range. And we also don't want it optimizing stuff outside of our optimization range. So make sure your PEQ limits are set to the same thing as your optimization range. We'll get into the maximum cut and maximum boost here in a minute. Typically, there's no reason to change the min and max Q, but you might need to change this just depending on some of the limitations that you might have in your particular DSP platform. Constraints. This is something that we'll talk about in a few minutes. This is used to help us limit the effect of stacking PEQs. So one thing that can happen is you can end up with multiple filters that have the same center frequency, but different gain or cut values. And for example, you can see in my graph here for my response, hey, I've got a pretty big peak for a lot of this at about 25 hertz. Well, maybe it puts a narrow filter here for something, but then it puts a really wide filter here to take all of this stuff down. Those multiple cuts can end up stacking, and you can end up with really odd dips and really odd performance once it's implemented. So we'll talk about how we can limit that. We are not going to use a target curve, and that might be a little heretic for folks that are used to doing your optimizations for a single position with something like REW. What we want to do is we want to decouple our target curve from our sub alignment. Most room equalization platforms, Odyssey, Dirac, which is what I use, Anthem's ARC, all allow you to specify a target curve within the Room EQ software. So that's what we really want to do, because that lets us change our Room EQ and change our target curve without having to go back and recalculate and potentially realign and mess up our sub alignment once that's done. So we're always going to EQ to flat within MSO. If you start going through some of the documentation that Andy has out there for MSO, he does a much better job of explaining why we want to decouple these things. But I can also show you a few different ways to set up a house curve the one that I've used in the past with Yamaha's YPAO in particular, that make things really, really easy to implement, right? And then the last bit on here is group weights. We don't need to worry about this. These really only come into play if you're using the as flat as possible method, which we're not going to use. So we'll go ahead and we'll click OK.